Good afternoon, KAIST students. This is Seungmin Lee, student of Quantum Chemistry MS310. Are you interested in computer? We use computer in daily lives, like doing homework and playing games. And if you are university student, you can't live without one day without computer because you should watch Zoom to participate to your class. However, computer can do other things which is really important. It is calculation and solving problems of nature. To do this, you need to use a computer which has very high performance, like supercomputer. But it is fact that increasing performance in classical way like decreasing size of IC such has limit like noise by quantum phenomenon. So scientists are developing a new way of computing. One of these way is quantum computing. So today I am going to talk about how quantum computer works and how they are different from conventional computers. To understand how quantum computer works, you should understand about this question, why a quantum computer calls as quantum computer. The answer is simple because it uses quantum property. Classical computer does calculation with 0 and 1, but in quantum computer, they use 0, 1, and superpose state. And you can even make entangle one state to another, and we can control this using interference. So to understand how quantum computer works, you should know about superposition first. So I am going to explain about this briefly. So as you know, superposition means that two states can coexist before you watch. As a famous example, Schrödinger's cat, you don't know whether the cat dies by cyanide brand or not before you watch. Before you watch, the cyanide brand leaks or not and cat dies or stays alive. So we use this property to quantum computing by making a qubit. Simply, a qubit is a bit of quantum computer. Qubit is a system that can make and control superposition state. As an example, in photon, we can match vertical polarization to 1 and horizontal polarization to 0. Also, photon can have property of superposition. So qubit can be an ion trap, superconducting material, and quantum dot. Any system that can make and control superposition state can be a qubit. Now think about situation that we have many qubits. If we want to solve the problem, you should encode this problem to the complex quantum state, and we should conduct calculation and manipulating them. We can do this by changing quantum states and making entanglement. Entanglement means if one system's state has been decided, then physically entangled other system states can be decided. For an example, in superconducting material qubit case, we can make entanglement and change quantum states like make superposition state or flip their spin by using microwave pulses. And also, we can watch the result by using microwave. In this process, microwave interacts with them by using interference. We use constructive and destructive interference to control quantum states and amplify the signals. So, as a result, can you expect what you can have? We can get probabilistic result. We can get the one probability to be 1 or 0 in one qubit. So how this result can be an advantage of quantum computer? It is simple. In normal computer, if there is n qubit, we can put n number of information in it, but in quantum computer, if you have n qubit, we can put 2 times n number of information in it, so we can put much large information in same unit. So we can handle much large information in quantum computer, and as it is, it can be much faster than conventional ones. So the way of quantum computer calculate is quite different from conventional one. For an example, if you should find an ext of this maze, in conventional calculation, you should calculate like this. Match 0 to left and 1 to right. Then, first branch left, no. Then go back to the start point. First branch right, yes, and second branch left, yes. Alright, and third branch left, no. Oh, then go back to the second branch. And third branch right, yes. Then we can find the ext. We can think that conventional way we are doing it by one case and find the result. But in quantum computer, we can do calculation like this. First branch left or right, and second branch left or right, and third branch left or right. And like doing this, the most accurate way to get to the X appears first. If the maze is simple like this, the time it takes won't be much different. But if maze gets bigger and bigger, then quantum computing would be much faster way to solve this problem. So, it is quite swifty example, but I think it'll be enough to help your understanding. So in this manner, quantum computer can solve complex problems in the nature, like atomic bonding, orbital overlap, machine learning, and searching algorithms, and of course, cryptography more efficiently. Quantum computing is thought to be important in solving problems of the nature and that have not been solved. So I think it is good to have simple information about it. So, thank you for listening, and this is my reference.